Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In our last video tutorial, we continued working with our 100 points that we created to generate time series, specifically snow cover time series for those 100 points. And we roughly divided those 100 points equally between 50 that would have received snow at some point during this 23-year period. Remember the data product from 2000 to 2023. And then the 50 locations that most probably have never received snow. So we've got the 50, the 100 locations. And then we generated the snow cover data on a daily basis for each of those locations from 2000, which is something like 900,000 observations. And then we transferred it into, or we exported it to our Google Drive and moved it to our project folder on my laptop. And then from there, we opened the CSV, and from the CSV, we went into Excel. And within Excel, I used the sum if criteria for two sets of criteria. And when we move from the daily data into monthly time series for each of the locations from 2000 to 2023. And then we played around with it a bit in Excel, and we also moved it into QGIS, and we played some work, and ultimately we created a little heat map of snow cover for 2023. So that was quite neat. But what I want to do now is to say, okay, we don't want to just work with the snow cover. We actually want to bring in some of those other variables, such as the climatic characteristics and the terrain characteristics. So I want to build a panel data. Okay, so I want to create a panel data set for each of the locations. Okay, in time series format, monthly data from 2000 to 2023 for the different characteristics, i.e. snow cover, maximum temperatures, minimum temperatures, rainfall, wind speed, then terrain when it comes to elevation, hillside, slope, etc., etc. So that we can say, okay, for that specific location, in time series format, there's the 6 variables. This is how much snow it occurred when within time series. This is the temperatures, this is the rainfall, blah, blah. I think hopefully you get the picture. So we're building one massive basic data set here, and obviously we can then use it for modeling purposes and the like. Okay, so sorry about that. Okay, so we're going to continue with that. So the first thing that we want to do is I'm creating a new script. Okay, I'm creating a new script. So this is my original script. The SnowTut1 is my original script, my original project. Okay, where we generated all the data, the images, and we generated the 100 points. And at the end of the day, we basically generated the daily data using this script. And we've basically said that it's important to note that we have to generate a data set or a feature collection of these 100 points, but with that added point column. Okay, that random point column. Remember that. That is in previous. Okay, so and we've created this featured location, which we call snow cover points, which basically added this point. So what we're gonna do now is I'm first gonna work with my climatic data set. Okay, data product. Okay, so I'm just going to generate the climatic variables, and then the data for that climatic variables, and then we're going to add it to those 100 points. Same logic as previously. First thing that we have to do is we have to create a feature collection. Okay, in this case, I'm working with an original feature collection, which was called point, and I'm adding the column, but where in this case I called it snow cover points. In this case, I call it maximum temperature points. Okay. So for each of these climatic variables, I'm going to generate a table, okay, and that table will be unique for that band that we, or variable that we're going to create. So when I do minimum temperatures, I'm going to generate a feature collection, okay, with that point, but I'm going to call it rather maximum temp, I'm going to call it minimum temp, and I'm going to use that then to upload it. So where we left off in the previous script, remember we created this point collection, okay, which is basically this one here, table 2, which is our point collection. Okay, this is what we've created. Okay, so this is this is what we've created. This one here. Okay, snow cover points, and that basically that feature collection. This one here, this feature collection, we're going to continue to use the geometry one. Okay, we're going to continuously use that, which is the 100 points. Okay, so because I need a feature collection where I'm going to add my data to, and I'm not using the one, the snow one, the snow cover points, because the snow cover point is in daily format, not in monthly format. Okay, because our data is monthly. Okay, so that's why I'm using this one. Now, I'm sure we can use this for minimum temperatures as well. I don't think it should be a problem, but we'll get to that point at some point. So I've loaded my 100 features, my 100 points. Okay, my 100 point feature collection, and with an extra column which is called point. And if you just want to make sure, go to that. You see there's the columns, and there's my point. Okay, you'll see there's the point. So it is generated. Then I basically just load my image. Okay, remember, if you can remember back to the climate needs to be scaled. Okay, and specifically our temperatures needs to be scaled by 0.1. So that's why we have this particular part in here, because when we select our images, basically remember our Terra climate goes back from 1958, but we're not interested in 1958 because our snow cover only starts from 2000. So if you look there, there's my snow cover. Let's go up there. There's my snow cover. Okay, in this case it's still 2023 because we created the image. But if you go to the data itself, then you'll see it's from 2000 to 2024. Okay, so we know the snow cover. So obviously we have to use the same dates, but remember our Terra climate unfortunately only ends in 2012, December 2022. So therefore we can only go to December 2022. Okay, so that stops at December 2022. In this case, we're selecting our maximum temperature band, and when we obviously scale it. So in this case, we're generating our image collection. Okay, we're generating our image collection, and here we're generating our feature collection. Remember, feature collections is the 100 points, and our image collection is the actual variables. Now, we have to bring these two together. Okay, and this is what this script is about. And we use the normal triplets script, normal triplets codes. And remember, in this case now, because I'm with maximum, I'm not using the sum like in snow. I'm using medium. I'm using my TMMX maximum temperature band. Scaling is 1000. Everything is still exactly the same. Remember, there's that column that we've generated, that point column. And then I export it to my Google Drive. Okay, so exactly the same as we did previously, except here we work with monthly data, starting from 2000 till the end of 2022, and specifically maximum temperatures. Now all I can do is now change this to minimum temperatures. This one here, run it again. It will generate a table of minimum temperature. Then I can do wind, etc., etc. So all I do is I change the variable here. I change the variable here. Okay. So now once I've run the code, remember there's no images, no nothing. You'll see there comes my, it will show it now. There's the table that we've generated, and you basically just run. I'm not going to run it because I have already run it. There it sits, TMMX. Okay, this should process also now be familiar with you. And obviously from there I go find it. It sits within my Google Drive. There it sits. Okay, and then if I can open it here. Let's see if I can open it. Open with, let's just go with Google Sheets. And we'll open now, remember, as a CSV file because we've saved it as a CSV file. Okay, there we saved it as a CSV file. there it sits. Okay. Now, obviously from here, okay, there's the points. Remember, there's the points, and there's the coordinates for each of those points. And remember, it's in the right format because we use the scaling of 0.1. So this is not 280, but 28 degrees. Okay, so this should also now look fairly familiar. Now, obviously from here, I go basically to File. I can then I can go and download the data into Excel or whatever the case, or to CSV. Doesn't matter. We can now go and, let's say we download it to Excel. From here, takes some time, sadly. Okay, so let's go TMX Excel. I'm saving it now to my project folder as an Excel worksheet. It will basically there, it's done. Let's open it quickly, and there it's there it sits. And I'm just enabling. And voila, there's my data. Okay, you'll see 2000 second month, 2000 third month, 2000 fourth month, 2005th month. If I go right to the end, you'll see there's it for my points. It stops at December 2022. There's it for each point, and each point does and it has its own coordinates, X and Y or lat and long. Okay, so basically what I now do is I copy this and I am adding it into my spreadsheet. Okay, and there I've brought it in. Where's MT, maximum temperature? Okay, so I've created the spreadsheet here. Ignore these 2 points for now. Okay, I've created the spreadsheet. Now this is the SC, stands for snow cover. So that's the snow cover for each point. So I'm just adding a snow cover. Otherwise, you can have 2 points, one for snow cover and one for maximum temperature. You're not going to know which one is which one. So I'm just giving each location a unique ID, not in terms of the point number, but in terms of the variable itself. Okay, so I hope that makes sense. So you'll have 27079. You'll have 2 points, but one with the SC in front and one with the MT in front. Okay, I'll show you now. And so that's the date, the year, the month, each point, and each snow cover from February 2000. Okay, so let's quickly, if I minimize that now, if I quickly hide this, you'll see now, oh, there we go. And if I hide this now, you'll see there's the 2. Okay, so let's quickly make this a bit bigger. Okay, so yeah, just go and have a look and see. And if I go this one, you'll see exactly the same 079, 068475. You can see there 299. The only difference is they have an SC on front and this one has an MT on front. So I know this is the snow cover and this is the maximum temperatures. And that's why I've got these 2 things there, and I just add them together with this little formula in Excel. So I take the location and I add, in this case, is SC for snow cover. I've got location, I add an MT using this little formula with that little underscore there that binds it to, and that's it. So now I've got 2 variables for the same location. So remember, it's one location, same location, but 2 variables. One that indicates the snow cover per period, and the one that indicates the maximum temperature. So for February 2000, that location, 79, etc., had snow cover of 0 and a maximum temperature of 28 degrees. Let's have a look and see when it snowed. There it snowed in June. It had 1.14 snow cover, and it had a maximum temperature of 16.6. You can see very low warm temperature, maximum temperature. Look there, 1.4, 1.97 at 14 and 14. Look there, 0, 23, 0, 27. That should not be any surprise. That the colder it is, the lower the maximum temperature, the more snow. But obviously not in all places, because there are places where it doesn't snow, because it's not just the maximum temperatures. So let's, for example, go to a location. Let's undo, because not all locations, it's not just maximum temperatures that cause snow. Okay, so what we need to do now is obviously also, this is where the terrain comes in and so forth. So let's quickly just unhide them all. Okay, so let's go to 2 sites which we know didn't have snow, and this and this is the last ones here. So let's go to the last one here for maximum temperatures. Let's go there. Let's make sure it's the same site. Hide. Let's make sure it's the same site. And yep, it's the same site. 09947 end with 1461. 09947 ending with 1461. You can see here, if we go to 14 degrees, still no snow. So there's other factors obviously also, but it's a necessary condition that it must be cold. So that's a necessary, but it's not a sufficient condition. Sufficient condition is that it's cold plus it's high elevation. Okay, just having it cold doesn't necessarily mean it will snow. Just have a high elevation doesn't necessarily mean it will snow. But if you don't have cold temperatures and you don't have high elevation, it will definitely not snow. So the reverse is true, but the positive is not true. Therefore, we say they are necessary conditions, but they are not sufficient conditions. And this is what we want to do in this particular exercise, is to add more and more variables. Let me just unhide. Don't want to lose this because this is quite a lot of work. I don't want to lose any of this, okay? So you can see what I'm doing here. Well, so we've got now a data set. This is a panel data set. A panel data set, we've got locations, we've got time series, and we've got variables. So for each location, we have different variables in time series format, meaning it's panel. And therefore, we can do all sorts of panel work with it, which is beautiful stuff. Okay, we're going to add more variables to this. We're going to add more climatic variables. And then what we're going to have to do is to bring in the rain variables. But remember, the rain variables is done in time series format because those images are once-off images. So we don't have, and the rain doesn't change. So we'll work there with a cross-section, not with panel. Okay, so not going to go into the details, but okay, so this is what we have done now for this particular exercise. We have gone into our code. Okay, we've gone into our code, into our original script. From our original script, we generated a new feature collection, which we called Maxtemps. That's that point. And then we generated in time series format maximum temperatures. So what I can do is I can also go TMMN, because TMN is minimum temperatures. So let's quickly do that. So we go here and we amend this to be minimum temperatures. So let's see, everything else stays exactly the same. There's 3 places where we have to change the band details or the variable details. The rest stays exactly the same. And here I'm just going to make it TMMM, paste TMMM, paste TMMM. We put a CSV, we click run. And let's have a look and see. We should get now, we've got 2 prints. One, which is just a print for a particular, there we go, image ID, minimum temperature 13. Here it is for that specific ID, location, all the minimum temperatures task. Let's run it. Remember, it should now open in my project folder in this one here. Okay, so let's have a look and see what transpires. Let's close this for now. Okay, and better. I think you get the idea. Let's remember always to save. Now this is, as I said, you can use the script to download any and all time series images, but it has to be an image collection. And before you can do that, you have to create your feature collection, meaning create your 100 points with that additional column. It's going to take a bit of time. It's not that much, so it shouldn't take too long. Let's see if we still have time. There we go, it's done. Let's go to our project folder. There it sits, TMNN, and we're going to go and say open with, and we're going to open it as in a Google Sheet. And then in Google Sheet, there's my temperatures, perfect. I'm going to go File, I'm going to say Download as an Excel spreadsheet. And I download it into my tab. Let's call it Excel minimum temperatures. Remember, this is now, so this is the, so for each month, remember there's daily temperatures. So that's now the average of that 30 daily temperatures is now the monthly temperature. Okay, so let's quickly go there. Let's open it, which we've just created now. It should sit there nice and nicely. Let's enable. And all I'm going to do, I'm going to go to this particular one, and I'm going to go to this last one here. I copy it like such, like as is, and then I'm going to my snow cover one, and I go to this one here, and I basically just copy the values in, justify it, make sure. Oopsie, why is it not doing that? I think I need, it's not in time series format. Let's have a time series. Okay, so I have to transpose it. So let's make sure we space special, values, transpose, and then justify it quickly. We should go, hey, slow. Perfect. You see, it won't go to the bottom because these ones are 2023 data, which we have for snow, but we don't have for maximum temperatures or minimum temperatures. So all I now need to do is I need to create this as well. So we're going to go to this point here, and I'm going to say this into my location. Then I'm going to say it's, let's call it minimum temp. That's maximum temperatures. Can't be minimum. Let's make it N for minimum temperatures. And that is just binding the two. And there we go. And if I left side that, you'll see now, oops, you'll see it's minimum temperature. And all I do is I just drag it to the right. And that should be my 100 locations. Okay, it should be my 100 locations and the minimum temperatures. So let's quickly have a look at the three together. So let's go. I've generated a pivot. Okay. Let's leave the pivot out for now. Let's just quickly go and generate a location where we have the three variables together. So I'm going to hide that. And then I'm going to hide all the maximum temperatures and get the first minimum temperatures. There we go. And we're going to make sure that we have the same location. There they sit. Three of them. Let's make it a bit bigger. Let's make that one bigger. That one bigger. So exactly the same locations. Then you can see that. Same locations. 944, 944, 944. Snow cover, maximum temperatures, minimum temperatures. So there's three variables. That's what I'm saying. Same location, three variables in time series. That is what we call a panel data set. And therefore, we can run panel regression, panel co-integration, all of these nice things. Okay. Let's have a look at snow. You can see there. Let's have a look and see where it snowed quite a bit. In fact, let's quickly do this. Do that one. You see it stops, and unfortunately in see this is in 20, so we'll have to adjust our graphs. So there's the three variables. Let's put them on a single graph. There they are. So what I'm going to do is see, I'm going to put this one at a secondary axis. But you see this one also doesn't work. So ideally, you want to convert them all into the same format, which we can do. Which we can absolutely do, because these are, so let's do this. Let's copy this. Actually won't work. Yeah. We're going to copy these ones, and then we're just simply going to divide them by, let's say, 20. And this we're going to divide by 10. And then we'll get the same sort of level data, and then we're going to overlay it. Okay, but anyway, that's what we can do. So this is what we are working towards. This is what we are working towards, is to creating this data set, panel data set for snow and climate, and then a cross data set for all three of them, but only on 2023. But we'll get to that. Okay. So as I said to you guys always, everything starts in Earth Engine. Everything is, that's your source of all the information on all the images and all the data. It's always Google Earth. Okay, and then as I said, from there I like to branch out to Excel for data and QGIS for images, etc. Anyway, something different a little bit. Maybe you find it, hopefully you'll find it interesting. I find it indeed interesting because, as I said, it's not just about working in Google Earth Engine. It's because although it starts with remote sensing, it's not just limited to remote sensing. It's linking remote sensing to other programs, software, ideas, etc., etc. And that's, to me, the beauty, is integration of this. That's why I like, because this data otherwise would not be available, and you can't work in Excel or QGIS without the data and images. And so this is the beauty of remote sensing. It's the ability to get this stuff going together. But I hope you see where I'm going towards this. This is to create a picture of snow so that we can model snow going forward, or develop a model for snow, or develop ideas around snow. And this is the beauty of it. Okay. Yeah, fascinating stuff. Well, thank you for joining me on this journey. I really appreciate your company. If it wasn't for you, I would have stopped a long time ago. So it's nice to have your company on this journey. Please, guys and girls, boys and girls, remember to like, subscribe, share the video. It will make all the difference. Knowing that you support my work, it would be so much appreciated. And then stay tuned. I will see you on the other side.